Hello geometry students, and welcome back to another video. So, you know what to do. Try the problem in your notes, pause the video so that you can do it without me, but then replay the video to see how I did it. So, we are told to solve the equation and justify each step. So, first, anytime I solve an equation, I want to get rid of those parentheses first, so I'm going to do 6 times 2, 6 times negative b, so we'll get 4 equals negative 10b plus 12 minus 6b. Now, why was I allowed to do that? Why was I allowed to distribute the 6? Well, I used the distributive property. The distributive property is the justification for that step. Okay, next I notice that I have a negative 10b and a negative 6b. Let's just put those together. So I have 4 equals negative 16b plus 12. And now that's just simplifying or combining like terms, whichever you want to use. And now, to solve, I need to subtract 12 on both sides. Why am I allowed to do that? Subtraction, property of equality. Property of equality. And now I get negative 8 equals negative 16b. And again, that was just simplification. And now, to get b by itself, I'll just divide by negative 16 on both sides. Why am I allowed to do that? It is the division property of equality. And I get negative 8 divided by negative 16 is positive 1/2 equals b. And we simplified to get there. So cool, look at that. We solved over here, we justified our steps over here. Beautiful. Beautiful. Alright, let's move on to the second part of chapter 2.4. So we are still in algebraic reasoning. Now we're moving a little bit away from the addition property of equality, subtraction property of equality, and we're going to dig a little bit deeper. We're going to look at some more algebraic properties that some people consider more geometric properties anyways, but the learning target for today is that you know what the reflexive, symmetric, and transitive properties of equality are. And our success criteria is that you can use these properties of equalities in problems involving segment lengths and angle measures. So let's jump right into it. What are these reflexive, symmetric, and transitive properties? I am going to ask that you write this in your notes, at least this. We're going to talk more about this in the next couple of videos. But for now, I want you to know that the reflexive property is when we say A equals A. These are the same thing. This equals this. It's the same thing. And the way that I remember that is it's like A is looking in a mirror and it's seeing itself. A equals A. A equals itself. So that is the reflexive property. The symmetric property is if A equals B, then B equals A. If A equals B, B equals A. I can flip them around and it's the same thing. So the way that I think of that is symmetry. If this is a line of symmetry, I have B here, B here, and A on the other side. So this property is symmetrical, is how I remember that one. Now the transitive property states that if A equals B, B equals C, then A equals C. So this is like if X equals 5 and x equals y, then y equals what? Well, x and y are the same, and x is 5, so y is 5 as well. That's what the transitive property says. X is 5, x is y, which means y is 5. So, those are the 3 properties we're going to talk about today, and we're going to use these properties in some examples. So, first up, using properties of equality with angle measures. So, you are reflecting a beam of a spotlight off of a mirror lying flat on a stage. Why would you do that? Lights and mirrors, magic tricks, that's all I'm saying. I watch a lot of Penn and Teller Fool Us. But also physics. Light bouncing off of a mirror. How does that work? Images bouncing off of a mirror. How does that work? So, we're reflecting the beam of a spotlight off of a mirror. Determine whether the measure of angle DBA is equal to the measure of angle EBC. I need to find where these angles are. D, let's see, oh, you can barely see that, but D is there. So DBA is here, and let's use a different color for EBC is here. EBC. Okay. Now, another thing I don't want you to forget about are these markings right here. Remember that means that these angles are congruent. So they're telling us in the picture that the angle the light bounces onto the mirror is the same as the angle the light bounces off of the mirror. So, these angles, the purple angles, are congruent, is what they're telling us. So now the question is the red angle congruent to the blue angle? What do you think? Before we even flesh this out, what do you think? Do you think yes or do you think no? Pause the video and think about it for yourself. Should the red angle be congruent to the blue angle? Or are they going to be different? Okay, so let's think about this. We know that angle 2, or excuse me, the measure of angle 1 is the exact same as the measure of angle 3. We know that. They told us that in the diagram. And, wait, the blue angle is just angle 1 and angle 2 put together. Okay, so the blue angle, EBC, is just angle 1 and angle 2 put together. Okay? I'm not sure if this is helping us, but this is just, we're just thinking it through. And the red angle, I can see, is 3 and 2 put together. So the measure of angle DBA is the measure of angle 3 plus the measure of angle 2. Wait a minute. The measure of angle 1 is the same as the measure of angle 3. So if I have measure 1 plus measure 2, or excuse me, measure of angle 1 plus the measure of angle 2, that's the exact same thing as the measure of angle 3 plus the measure of angle 2. So these do have to be the same. Because 2 is the same as itself, and 1 and 3 are the same. Yeah, it makes total sense that these... Whoops, want to keep that there. It makes total sense that these are the same. Because 1 and 3 are the same, and you're just adding 2 to both of them. Okay, I think that's what I'm going to write. Yes, measure of angle DBA is equal to the measure of angle EBC because measure of angle 1 is equal to the measure of angle 3 and you just add the measure of angle 2 to get the red and blue angles. So this logic, this reasoning of what do I know? What can I see from the diagram? Ah, now all I need to do is put the pieces together. This logical thinking of what am I given, what steps can I take, this is what math is all about, and this is why I love geometry. So, they just said determine whether they're equal, and I say yes, they are equal for this reasoning. We can check and see if we are correct. Oh, they gave a full-on proof. They didn't tell us to give a full-on proof. We're not going to do that for now. But yes, they also arrived at the same conclusion. So now, we didn't do a proof in the last one because we were just getting our thoughts down. We were just getting the logic flowing. For this one, we will write a proof. It won't necessarily be super rigid, but we are going to start thinking about how to write proofs, because next section 2.6 is all about proofs. But I just want to get our feet wet right now. I don't want to scare you with proofs. We're just going to get our feet wet. So, a park, a shoe store, a pizza shop, and a movie theater are located in order on a city street. I already need a picture. That is so much information. So, let's see. A park, a shoe store, a pizza shop, and a movie theater are located in order on a city block. The distance between the park and the shoe store, so park and the shoe store, is the same as the distance between the pizza shop and the movie theater. Oh, so these are supposed to be the same. Okay. Need to redraw my picture. So let's see. What was this? Pizza shop. Oh no, we have two P's. That's not gonna work. Okay. Pizza shop is gonna be Z. It's pizza. Sure. Okay, so now the distance between the pizza, or the park and the shoe store, and the pizza shop and the movie theater are the same. So I'm just marking this diagram. I know that this is the same as this, and that's what the tick marks tell me. So I'm writing the tick marks. Save me some space. Show that the distance between the park and the pizza shop is the same as the distance between the shoe store and the movie theater. Do you believe that? Do you believe that the distance between the shoe store and the movie theater is the same as the park and the pizza shop? Pause this video and decide for yourself. Is that true? And then think about why. Why is that true? When you unpause the video, I'm going to be talking it through myself. So, first thing I notice, well here, actually, if I just draw a line right here at S and Z, I already know that these are the same. They told me that the distance between the park and the shoe store and the pizza and the movie theater are the same. And now this distance is the same. So yes, yeah, they're going to be the same. Because this is the same as this, and this distance ain't changing, it's the same chunk. So now all we have to do is show this mathematically. So I need to write what we just said. I'm going to write it in math speak. So, first thing we will write is PS, segment PS is congruent to segment ZM. Those are the same. And actually, maybe we won't even say congruent. We'll say the length of PS is equal to the length of ZM. Okay. Now, what we wanted to look at, the distance between the park and the pizza shop. So PZ. So PZ is something we want to look at. And the distance between the shoe store and the movie theater. Shoe store and the movie theater. And then SM is also something we want to look at. This is all we've been told. This is what we have so far. Now, what we need to do is we need to connect these dots in order to show that PZ is the same as SM. That's what we want to do in the end. In the end, it said, show that the distance between the park and the pizza shop, PZ, is the same as the distance between the shoe store and the movie theater. So if they are the same, they must be equal. So in the end, I need to show that this is true, in math speak. Okay, so I need to somehow get from here to here. And what I'm going to do is I'm going to take steps to get there. We're not just going to jump there all at once. We're going to take steps to get there. This is how proofs work. Okay, so what do I know about PZ? What do I know? Well, PZ is, it's PS plus SZ. That's the segment addition postulate, right? If I take this chunk and I add it to this chunk, I get the whole chunk. So we're just using the segment addition postulate. PZ is equal to PS plus SZ. Okay? Hey, I see PS here and PS here. Maybe I can connect those eventually. But right now I don't see anything I can do. So let's work with this SM. What do I know about SM? Well, I know the same thing. I can do the angle addition postulate again. SM is ZM plus SZ. Oh ho ho, look at that. I have two SZs here. Okay, okay. So, what I want to do, okay. What I want to do in the end is I want to show that PZ is the same as SM. So, if I can show that this is the same as this, that's the same thing as showing that PZ is equal to SM. It's like, here. That, I kind of confused myself there for a second. So PZ equals PS plus ZM. So PZ is equal to PZ plus SM. So the red box and the red box are the same. We know that because of the segment addition postulate. And now, we know that SM is equal to ZM plus SZ. So the yellow boxes are equal because of the segment addition postulate. So in the end, I want red box equal to yellow box, right? That's what we talked about before. I want red box equal to yellow box. So, if I can show that this red box, PS plus SZ, is equal to this yellow box, ZM plus SZ, that will be the same thing as showing PZ equals SM. Because PZ is equal to this red box, and SM is equal to this yellow box. So if I can show this, we win. Okay, so now, how could I show this? How could I do that? I need to look at what I'm given. I need to look more closely at this stuff right here. I've worked with this stuff quite a bit, but what about this guy? PZ plus ZM. PS is here, I see. And ZM is here, I see. And then oh, here it is, here it is, here it is. Okay. And then ZM is on both sides. So, stick with me, stick with me. we know that PS equals ZM. We started with that. That's these tick marks right here. We started off knowing that. And what does the addition property of equality state? It states that if I add something, if I add the same thing to both sides of the equation, I get an equivalent equation. So if I add SZ to both sides, I get this, and this is the same as this. Boom. Could not have done that, okay. We win. We win. So this might seem a little cluttered and a little scatterbrained. Let me show you their solution. It's a little more clean than mine. So, first thing you do when you're making a proof is you want to understand the problem. So that's what we did. That's what we did when we first looked at, okay, PS, PZ. That was us understanding the problem. Then we make a plan. Our plan was I need to get to this. I need to get to PZ is equal to SM, and I'm given these three things. So my plan is to use these three things to get here. Okay, so that was our plan. Third, solve the problem. So, what they did, they started off with PZ equals ZM, marked in the diagram. Next, different color. They took PZ, yes, PZ is equal to PS plus SZ. They used the segment addition postulate. We talked about that too. Then they did SM. Okay, they did the same thing on this side. SM equals SZ plus ZM. They did the same thing as us. Segment addition postulate. And then they took this and they added SZ to both sides of it. So see, PS equals ZM, and they added SZ to both sides of the equation. And now, they used the substitution property of equality. Get a different color. They used the substitution property of equality because PZ, different color, PZ plus SZ, that was the same thing as PZ. So I can change this to be PZ, just like ZM plus SZ, that's the same thing as SM. So we can change this to be SM. And then the last step that they did was to look back, reread the problem, make sure your diagram is drawn precisely using the given information, and check the steps in your solution. Which is what we just did. We kind of went back through it. We had our jumbled thoughts up here, and then we came down here and we solidified our thoughts. And we said, okay, these are the steps we took. So, if you are still confused about what just happened, that's okay. This was the first, real proof we did. I encourage you to read this a little more carefully, or not carefully, but a little more thoroughly, to make sure that you understand each piece of it. These different color. These equations over here, this is the math speak. Here's the explanation of what we're doing in that math speak. And these are the reasons, these are why we are allowed to do that. So in order to understand proofs, I really, really want you to be able to look at a proof and understand it. If you can look at a proof and understand it, then you can get more and more comfortable with writing your own proofs. But if you don't understand, how proofs are written, how are you supposed to write your own? It's like if you don't understand how an essay is written, how are you supposed to write your own? So, rewatch the segment where we were doing our thinking up here. I went through it I tried to go through it slowly, but rewatch it. Rewatch it until you truly understand it, because this is the most important part of math class. Okay. If you have questions, that is normal. I did not understand proofs in high school. My geometry teacher, that's the reason I became a math teacher, was because my geometry teacher taught me squat. They taught me nothing. I had no idea what proofs were. So when I got to college and we're banging out proofs left and right, I'm like, what? What is going on? I really want you to understand proofs so that you don't get to college and you're like, what is going on? So, if you have questions, please, 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 talk to your teacher, talk to a friend, see if you can reason it through. Even if your friend doesn't know what's going on, see if you can just talk to each other and figure it out together. Yes, get those questions answered. Okay, practice problems. There are a lot of practice problems for this section. There are these practice problems, and then there are all of these. So I intentionally gave you lots and lots of practice problems because the more comfortable you get with proofs, the easier they become. I know that you don't want to do things that are uncomfortable, but the more you do them, the more comfortable you get. It's like taking cough medicine. I hate taking like NyQuil or Dayquil or something, but the more I do it, the more comfortable I get with it, the more I'm like, it's not that bad, we'll just get it over with. And not that proofs are that bad and you need to get over them, but maybe that is your outlook. Either way, get comfortable with them is the point. Get comfortable. All right, and of course, as usual, we're going to end our video with a launch. This launch comes from E.E. Cummings, and he says, "The most wasted of days is one without laughter." So a day is wasted without laughter. If you don't laugh, you've wasted your day, because laughing means you're having fun, and you want to have fun. Isn't that the point of life? To have fun and to help others have fun too. So this is your encouragement to laugh more. There are some things that you can cry about or you can laugh about. And sometimes you need to cry about it. I'm not saying you shouldn't cry. Never cry, just laugh. That's not what I'm saying. Sometimes you need to cry. And sometimes you can just laugh at it. Like, in the last launch, I told you about when I broke that cup. I could have gone, no, I like this cup. It's blue, it's shiny, and it's blue. I really liked this cup. Or instead, I could have laughed and gone, whoops, clumsy me. Guess I'll get another shiny blue cup at some point if I really want to. So that's the attitude I'd encourage you to take. If you can laugh about it, you can cry about it, and some stuff you just have to laugh about. Some stuff you just have to cry about. But if you don't laugh at all, if you go an entire day without laughing, kind of wasted, kind of. So I want you to laugh. I want you to have fun. So if you can laugh, laugh. That is my lunch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thank you for being here. Thanks for watching. Bye.